Okay, so this video is going to be about linear inequalities. So just going to kind of give you a good overview of all the little bits and pieces about them and stuff. These linear inequalities actually come in two forms. There's the and type of equations, and then there's or inequalities, and then there's the or ones. The and ones are the and ones are oftentimes written as compound inequalities. So you might have something like 2x plus 3 is less than or equal to uh, 5x minus 1 is less than or equal to 7x plus 2. Okay? So if I wanted to solve one of those, and I'm going to erase this so I have more room, then treat it just like you do an equation with three sides. If you do something to one side of it, you have to do something to all sides of it. You don't have to split it up into two different inequalities. So I would look at this, and the point is to get your x in the middle in this case. Okay, or you could separate out into two, and a lot of people find that a little bit easier. In a case like this, maybe it is because of all the x's that are running around. So I might consider just looking at this one saying, okay, well, let's just solve this thing for x. I think I will subtract 2x off of both sides. Okay. And that's going to leave me with 3 is less than or equal to 3x minus 1. Then I can add 1 to both sides. And that will be 4 less than or equal to 3x. Then I have to divide. Now this step, when you divide, that's where you have to be careful. Because if you divide by a negative number, you have to flip your inequality symbol. But I'm dividing by a negative 3. Doesn't matter what you're dividing into, just what you're dividing by. So we're going to be left with 4/3 is less than or equal to x, or you can read that backwards, x is greater than or equal to 4/3. So a lot of people like to have the x on the left-hand side, just reading it and stuff. You don't have to, though. So we have that, and at the same time, we're going to have this other equation where we have 5x minus 1 less than or equal to 7x plus 2. So let's see, I'm going to go ahead and I'm going to subtract 7x from both sides. No particular reason, just want to. Okay. So negative 2x minus 1 is less than or equal to 2. Then we can add 1 to both sides. That's going to leave me with negative 2x less than or equal to 3. Now we're going to divide by the negative 2. Now, since I'm dividing by a negative number, I need to flip this inequality over. Okay? So once that gets flipped over, we're going to have x is greater than or equal to negative 3/2. Now what we have to do, if we want to write this in interval notation, okay, I think the easiest way is to graph it on a number line. Okay? And to the and, you want to look and see where these two pieces overlap each other. Okay? So the x is greater than or equal to 4/3. So 4/3 is like 1 1/3. That would be, and it has an equal to, so I'm going to put a little dot there. Remember, just less than or just greater than, I would put a circle. So that's 1 1/3 if you use calculator to get a decimal if it helps on the number line. And the other one, x is greater than or equal to negative 3/2. So that would be here, and it goes over. And we want to see where is the overlap between the two. And if we can see the overlap starts here, it goes out forever in that direction. So the interval, it starts at the 4/3, and it includes it because we have that equal to part. So I'm going to use a bracket, and then it goes out toward infinity. So this was a compound inequality. So we can, when I write in the interval notation, I always use a number line to do that. You might also have something like just another one that has a different overlap. Something like this. Now, since I don't have variables all over the place, this is a case where I would just treat this like one big equation and say, you know what, let's just do it all at once. I'm going to subtract the 1, but I have to do that from all 3 sides. All right, so that's going to leave me with 3 less than or equal to 2x less than or equal to 9. Then I need to divide all these sides by 2 because I still want to get x by itself. So I'll divide all of that by 2, and we'll have 3 halves less than or equal to x, which is less than or equal to 9 halves. Now when I look at my number line, so let's see, 1, 2, 3, 4, that would be 5. And I'm going to graph. So I'm going to still take each of these kind of one at a time. So I'm going to look at that inequality. X has to be greater than or equal to 3 halves. So that's 1.5. So it's greater than or equal to that. You know what? I'm going to change the problem a little bit just to mess with you. And I want to change this one to a strict inequality just so we have not always a bracket. Okay. Now, the other piece that we're graphing then is the x less than 9 halves. So 9 halves would be 4.5, and it's strictly less than, so I would use a little circle, and it goes in that direction since it's less, right? So I want to look at the overlap between these two. The overlap occurs from here to here, and it's all that stuff in between. Now on this left-hand side, it includes it, and that would start where the blue one started, and that would be at 3 halves. But the other end is not included because it's not included in with that yellow circle, right? And so that was at 9 halves, and that would require a parentheses. Okay, so those are the and inequalities. The or inequality, okay, would be something like 5 is less than or equal to 2x plus 1, or 3 is greater than x minus 2. So we solve these two separately. So on this last one, I'm going to treat this just like I do an equation. So we subtract 1 from both sides, and 4 is going to be less than or equal to 2x. Then we divide by 2. That's going to leave me with x equals 2. Now on this other side, wrote out some real simple ones, right? So add 2 to both sides, then we're going to have 5 is greater than 5. 5 is greater than x. Now, for an or, when we do the interval notation, we have to do what we call the union of these two sets. We're going to join the graphs together. Okay? If I start all, let's see, 0, 1, 2, 3, 4, 5. 5. All right, so the x is greater than or equal to 2. So I'm reading that backwards, right? So x is greater than or equal to 2, going right to left. I don't know why. Just say 2 is less than or equal to x. It's kind of the same thing. But if x is greater than or equal to 2, that graph is going to look like this. If x is less than 5, oh, silly thing. If x is less than 5, lost my little dot, then that's going to go this direction. It doesn't want to keep my dot. Now, if I join those two graphs together, just imagine overlaying one on top of the other. Okay, then that's just going to leave one line that goes in both directions forever. So that's going to be a negative infinity to infinity. And let's do one more similar to that. Okay, so this should work like I want, I do believe. So we're going to have that one or this. So again, solving these, we're going to subtract, I think on this one, I'll subtract x from both sides. And x is going to be less than 1. Now we'll have a couple of steps on the other one here. So let's just add 3x to both sides. You know what? Just for example's sake, I'm going to subtract x from both sides. So negative 4x plus 2 less than negative 3. Then we'll turn around and subtract 2 from both sides. Negative 4x is less than negative 5. And now I need to divide by that negative 4. Now when I divide by the negative 4, I need to flip this little symbol over. So that's going to give me x is greater than or equal to a positive 5/4. Because we got negative divided by negative gives me a positive, correct? Now to write this answer in interval notation, so that's 1, 2, 3. Draw out my little number line. Here, x is less than 1. So my graph for that part is going to look like so. Over here, x is greater than 1 1/4. So 1 1/4 is going to be a little bit above the 1, and it's greater than, so it's going to go this direction. Now when I join those two together, it's not like they have any overlap or anything like that. So this is just the graph that I have. Okay? We're just sitting them side by side, right? So since there's no overlap, they don't like join together like the other one did for the negative infinity to infinity. Because notice up here, we had this little spot where if you laid one right on top of the other, they joined each other basically. Here, that's certainly not going to happen. So that goes from negative infinity to this first little spot where it breaks at 1. And then we'll put a U for union. And then the graph picks back up at the 5/4, and it doesn't include that either, but it continues out to a positive infinity from there on out. Okay. So I don't know. I have to look at the graphs for all of these inequalities to write them in interval notation. And if you just have a simple linear inequality that doesn't have the compound stuff, then you just have the one piece of the graph. Okay, so maybe this will help a little bit. Have a great day or evening or whatever it is.